Hello, good morning. Welcome back to another math workshop. Today we're going to continue working on our Unit 6, Fraction Concepts and Operations. Our teaching point for today is, I can add and subtract mixed numbers with like denominators. Today is Thursday, May 14, 2020. And our lesson for today is titled, Add and Subtract Mixed Number with like denominators. I encourage you to pause the video now and get to copy the date, lesson name, and teaching point in your notebook just before we get to continue. If you did that, let's get ready for our quick practice. In our quick practice for today, we have an anytime problem. It says as follows. Miss Martina paid Susan, Bernardo, Dwight, and Cheryl $13 for shoveling her driveway, right? How much money did each person receive? So basically we have $13 for 4 people. You can try different ways to actually get this answer. Anyway, right here I shared the answer with you so you can confirm your work. Now I'm going to share one way that I could try to solve this problem. I will try a proof drawing. Right here I have my $13 as you can see. But what I'm going to do now is that I'm going to divide them into 4 equal groups, and each group has $3. But I see right here that I'm still missing $1. And I know that if I divide $1 into 4, I will have 4 coins of 25 cents. So right here, if I actually include 25 cents to that previous amount that each one of them had, then I will notice that I will have $3.25 in every case. So right there, I can see that my answer is actually correct. Alright, in our previous lessons, we had the opportunity to talk about like denominators, and we learned that another way to call them is common denominator. When 2 or more fractions have the same denominator, we can add and subtract fractions only when they have a common denominator. So that means if you try to add fractions or subtract them and they don't have a common denominator, then you can actually do that. So far, let's only focus on fractions that have a common denominator. All right, we also took a look at adding fractions with like denominators. So we would take a look at this too. We're adding 3/8 plus 4/8, and that will be equal to 7/8. As we notice, the denominators stay the same when we try to add fractions with like denominators. The only thing that is affected, or that we actually do, is to add denominators. Right here in the visual, you can see the representations of every fraction, and at the end, how they add up to our sum. If we jump in right away to the equation and we skip these drawings, right here we can see that we have 3/8 plus 4/8 that is equal to 7/8. Yet again, we still have the same denominators, only added denominators. Right here, there's an important step, circling this red. That is a step that we usually follow, or that we actually follow when we add denominators. We usually don't include this step because we can do this mentally, but this is what actually happens. We keep the same denominator for both fractions, as you can see right here, and then we add on top as denominator the 3 plus 4 in this case, and you will see that that is equal to 7/8 in this case. Now subtraction is basically the same. We're still getting the same denominator. That means that if your fraction A and your fraction B has the same denominator, then you're staying with the same denominator at the end in your answer. Now, what I'm going to try again, in this case subtracting, is that I will subtract 7 from 4, actually 4 from 7, and then that result with my answer right here. Mixed numbers, what is that? All right, So basically a mixed number is a whole number, as you can see, a big one, and a fraction combined. So whenever we talk about mixed number, we're talking about a whole number and a fraction together. The way that we call this are, for example, 2.5, 1 3/5, 2 2/3, 3 5/6, 1 1/4. Basically, we call the whole number as it is. We include n, and then we just name the fractions that we already know, okay? Mixed numbers. We're still working on that. We also had the opportunity to convert fractions, actually mixed number, to fractions. How is that? All right, since we already have a whole number right here, what we do is that we express that whole number in terms of ones, right? Since I have 3 as my whole number right here, I will have 1 plus 1 plus 1. But don't forget about adding the fraction as well. In our second step, what we do is that we take those 3 ones in this case, and we make them a fraction. We represent them as a fraction. We already know that if we divide any quantity by itself, we're going to have a value equal to 1. So let's do something. Since we're supposed to add and subtract fractions with like denominator, that means that these fractions that we're trying to get equal to 1 should also have a denominator equal to 5. So what I'm going to do is that I'm going to take a look at whatever fraction I'm given in my mixed number, and that denominator will actually represent the denominator of that new fraction, but also the denominator. Because right there, my 2 conditions are met. And what are those? First, I need to have the same denominator in every equation, actually in every fraction, so I can add them. My second condition is that these 3 fractions that I just changed, they need to be, or actually have a value of 1. If I divide 5 over 5, that has a value of 1, right? Since I have 3 ones and I change them by this fraction representation, then right there, my equations still have the same value. All right, so keep that in mind. This denominator right here will tell you what the substitution for this one will be. And right there, as we already know how to add fractions with equal denominator with like denominator, then we're keeping the same denominator, in this case 5, and then we just add all the denominators together. That would be 5 plus 5, that is equal to 10, plus 5, 15, plus 4, 19. Perfect. However, sometimes we need to try the opposite. We are given a fraction, and we need to take that fraction into a whole mixed number, I meant. Sorry. All right. So right here, what we're going to do is that we're going to ungroup that fraction that we're given, 19/5. Or if we look for another perspective, basically we're reversing our previous steps. So what we're going to do now is that we're going to have our nominators that are equal to 19. All right, so we can try different combinations, but we need to keep in mind to have the same denominator, because this denominator will never change. This is 5, right? Now, since this is 5, then the denominator that I should have should be that one that allows me to divide by this denominator, and at the end is equal to 1. All right, so if I try a 3 at the top, for example, and I divide by 5, then my problem is just worse, because I won't be able to divide 3 by 5. So I want to simplify this in such a way that these fractions that I'm trying are equal to 1. But I want to still add up all my nominators, and at the end I reach my target, which is 19. Being that said, then we simplify these fractions, or we operate the division, and that would be equal to 1 plus 1 plus 1 plus our fraction. If we put together all the ones, then right there we got 3 plus my fraction that I just had. Alright, so today we're going to continue working on these exercises. I encourage you to pause the video now and get to practice a little bit on this. When you're done with this, let's continue with adding and subtracting mixed number with like denominators. Now this time you might find it a little bit more challenging, but if we follow the necessary steps, you will see that it comes real easy. Alright, let's take a look. Right here we have this situation. We have 2 and 2/5 plus 1 and 3/5. If we make a representation, a visual representation of these two mixed numbers, we're going to have the following. Right here we have 2 wholes, and right here we have 2/5. On the second item we have 1 whole, and right here we have 4/5. Right? Same denominators, that means like denominators. Basically what we do in these situations is that we add all the wholes together and then we try all the fractions together. There will be times that when you add all the fractions together, you will find a whole number, right? You will get a whole number as a result. So what you're going to do, that at the end, you're going to add all the wholes together and all the fractions together. That way, you will get your answer. Right here in this equation, I represent what I just said. First, I'm going to take the every whole that I have. In this case, I have 2 plus 1, okay? Plus, because I'm adding. And right here, I will have the 2 fractions that are 2/5 plus 3/5, all right? I'll sum them separately. And then we have this, where we have 3 wholes plus 5/5, right? If we divide 5 over 5, that would be equal to 1. And right there we have an example of what I just said, that sometimes those fractions can be equal to 1. Now 3 plus 1 is 4, and right there our result is present. If we take a look at these exercises, you're going to be putting that into practice. We have like denominators in every case. Keep in mind to begin adding the wholes, then add the fractions, and then have your mixed number combined, right? What we saw before just showed that even though we're adding mixed number, they can still give you a whole. Not always, but sometimes. Alright, let's try subtraction in this case. Subtraction follows the same pattern, right? But there's a special case that we're going to take a look in a moment. Alright, so yet again, we're going to begin by subtracting the 2 whole numbers, in this case 4 minus 1. And then we're going to try subtracting 3 sevenths minus 2 sevenths, as we have over here. You might wonder why this plus symbol right here if I'm subtracting. Alright, this operation applies to both cases. What we're basically doing is using the associative property that allows us to group the different items that we're trying, the different partners that we're trying in different ways without actually losing its main result. So right here, since at the end, whatever fraction I get or whatever whole I get, they're part of a mixed number, then that means that even though I get them separately, at the end they come together. So we have 4 minus 1, that is equal to 3, and then we have 3 sevenths minus 2 sevenths, you see, like denominators. I leave my denominator the same, and then I just subtract the denominators. That would be 3 minus 2 equal to 1. Perfect. Now I have a whole number plus a fraction. So that means that my answer and my whole number is ready right here. So my answer would be 3 1/7. We have a special case right here. Let's say, yeah. If we try the whole numbers, first we're going to see 2 minus 1. Okay, that's perfect. That's equal to 1. But when we try to figure out the result for the fractions, we're going to notice that they still have the same denominator, and that's perfect because that means that we can add or subtract them. But when we try the denominators, we see that we have 1 minus 5. Right now we're not working with negative numbers, right? So that means that we'll need to ungroup one whole, right? So that's why you see that I crossed out over here. So instead of having 2 wholes now, I will have 1 whole. Now, we already know that if we divide any quantity by itself, will give you a value to 1. But right here we have 1/8, which is a fraction. Now, that one that I just got here, I will represent it as 8 divided by 8. So if that fraction I added to the previous one that I had here, 1 divided by 8, or 1/8, I will have 8/8 plus 1/8, that is equal to 9/8. And that's what I have over here now, okay? So now I'm ready to try. 1 minus 1 wholes is 0, and then we have 9/8 minus 5/8. The denominators stay the same, and then we have 9 minus 5, that is equal to 4. In this situation, I always recommend that you try the fractions first. That way, you see if you whether need to ungroup a whole or not. In these exercises, you're going to find this situation where you are going to need to probably ungroup or try out a simple subtraction from exercises 11 to 14. Now, from 15 to 17, you don't need to do anything, but you need to take a look at the process they follow and explain every situation, actually every solution, how they got to that solution, right? Right here we have our friend Puzzle Penguin that is a little bit confused. So take a look at that situation yet again and write a response to Puzzle Penguin. Right here we're going to be comparing fractions the same way that we tried before. This time you need to convert every fraction to every mixed number, to a fraction, and then right there you compare the same way that we have learned before. Thank you guys. I hope that you have enjoyed this lesson. If you have any doubt, let me know. This video was pretty big long, I guess. But anyway, these are fundamentals to our fractions course. I hope that you have enjoyed, and see you next time. Bye-bye.